Hey 8th graders, it's Miss Crofutt. I just want you guys to add really quickly something to your notes, and then I'm going to go through them before we do our demonstrations for Newton's first law today. Alright, so in your OneNote, you guys should already have the section force and motion. So this little blurb of notes is going to go under force and motions. You guys have already added vocab and key concepts, and hopefully you guys have been doing what you're supposed to be doing and adding notes to there. Remember that you guys have those notes available to you for tests and quizzes. So if you're asked what Newton's first law is, that should be in your notes as of today. Okay, with that being said, you guys should click on Add Page down here at the bottom and add Newton's laws of motion. So over the next couple weeks, we're going to be talking about Newton's 3 laws of motion. Today, we're going to talk really quick about Newton's first law. And then we're going to show you guys some demos that kind of talk about Newton's first law. Okay, don't worry about Newton's second law today or Newton's third law. We'll talk about those here in a couple days. All right, so you should have gone to your Teams, and on today's Teams post, you should find this picture. So go ahead and copy and paste that into your notebook. So remember, if you're using a Chromebook, you guys copy by clicking with 2 fingers gently, and then it should give you your right-click menu of copy, and then Control-V paste it into your notebook, or you guys can save it and go to insert picture. Either way that works. Okay, so let's just go over these notes for Newton's first law. All right, so generally when we're talking about Newton's first law, we're talking about balanced forces, meaning if we're putting multiple forces on an object, one isn't any greater than the other. They're balanced and they shouldn't change motion. All right, so the main part, and you guys have probably heard this before, but the main thing about Newton's first law is that an object at rest is going to stay at rest, and an object in motion is going to stay in motion. Okay, so that's these 2 lines right here, and then you guys can see this little arrow that says unless. Okay, so unless a force acts on them. So let's talk about the first one here. An object at rest remains at rest. So if we have a soccer ball sitting in the middle of a soccer field, unless a force acts on that, that soccer ball will never move. Okay, if the wind blows, well, the wind is a force. So yes, that might move the soccer ball a little bit, but that's only because of this right here. Unless a force acts on them, the wind would be a force. But other than that, if no force acts on an object at rest, it will stay there for the rest of time. Okay? However, an object in motion remains in motion. So the big if on this is kind of a hypothetical statement. Okay? In our atmosphere, we have a little thing called friction. So assuming that we didn't have friction, this would be true. Okay, so an object in motion remains in motion. So if we were to kick a soccer ball and there weren't things like friction from air resistance or friction from grass or any of those things, that ball would keep moving forever. Okay, maybe it hit something, but then it's subjected to a force. Okay, so ideally that soccer ball would move on forever until something stops it because of a force it puts on it. Okay. So this is all of mainly Newton's first law, but there's also some other key concepts that go along with Newton's first law. So let's talk about this vocab word, inertia. This is an important word. Commit it to your memory. Inertia is something an object has, okay? It's a tendency of an object to keep doing what it's doing. So if we talk about Newton's first law, we said an object at rest remains at rest. That object has inertia. And it's gonna, if it's at rest, it's gonna want to stay at rest. Okay? If an object is in motion, it has inertia, it's gonna want to stay in motion. It's gonna keep wanting to do what it was doing, either resting or in motion, until something stops it. So something an object has, it's the tendency of an object to keep doing what it's doing. Okay? Here's the big thing is we can have different amounts of inertia. So let's take, for instance, a bicycle and a semi-truck. If you guys are riding a bicycle at 30 miles per hour and you guys have a semi-truck driving at 30 miles per hour, which is harder to stop? Is it the bicycle or is it the semi-truck? Both are going the same speed. Which takes more force to stop? Okay, you said the semi-truck, you're right. Why? Because it has a higher mass. Okay, so if you're looking at trying to stop something, that's hard. Okay, if it has a higher mass, it's harder to stop it. It needs a little bit more for force because that object with the higher mass has a higher inertia. Okay, let's talk about this. Let's talk about something that's at rest. Okay, even an object at rest has inertia. So you have 2 shopping carts. Okay, your first shopping cart is empty. Your second shopping cart is loaded up with 300 pounds of groceries, okay? Which one is harder for you to get going, to start pushing to your car, okay? The harder one is the one that has the higher mass because it has more inertia. Just because it has a higher mass means it has a higher tendency to keep doing what it's doing, which in the case of the shopping cart, it's remaining at rest. Okay, it's hard to get that shopping cart going. It would take more force to do that. Okay, so that's basically Newton's first law. You guys should have added this to your notebook. On your guys' final test that I give you, you will have a lot of questions about Newton's first law and inertia. You guys can use your notebook, so make sure this is in your notebook. I hope you guys are all having a wonderful day. I miss seeing your faces, and I will talk to you soon.